Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see about longest subsequence with decreasing adjacent difference. Now, make sure that you know this fact. This is not a medium problem. Its acceptance rate was pretty low in today's contest, and also I have made a quick short. I can just go and watch it, telling what's different about this specific problem and must know also. Cool. Let's start off. It simply says that you are given an array of integer called as nums. As you can see, you are given simple nums as an array. Your task is to find the length of the longest subsequence of nums such that, again, longest subsequence of nums. That's one big hint which I'm trying to move you towards, such that the absolute difference between consecutive elements form a non-increasing sequence of integers, which ultimately mean that whatever subsequence you choose, and I hope you know what a subsequence is. Subsequence is, if you have specific array like this, you choose some elements, and then after you choose those elements, let's say I choose x1, x3 and x6, these form a specific sequence and it is taken from this input array, thus it is called as a subsequence. It should be in order. The property which we need to make sure is that the absolute difference between the consecutive elements of the subsequence, so the consecutive difference, which is x3 minus x1, x6 minus x3, its absolute, again difference, it is this absolute difference, this is in the non-increasing order, which is decreasing or equal order, and ultimately give me the length of the longest such subsequence. Now, if I tell you, you have to find the longest subsequence with some condition on that specific subsequence. Did you remember any existing problem? I hope so. You must have. You must have heard of longest increasing subsequence and many variations of the same problem. Again, which infers that it is some form of a DP. But the fact here is that we have to choose some subsequence. And again, the fact here is that in the same problem, we have this kind of a fact. Okay, we have to choose some subsequence, as in, longest increasing subsequence. So, okay, we have to choose a subsequence with a fact or with the addition of that, okay, it should be increasing. And same way, here we have to choose some subsequence with the fact or with the addition of some kind of non-increasing difference of subsequence. Again, if we forget about the difference factor, still, if I just take the picture, okay, like just a high level picture, okay, I get an idea, okay, maybe I can apply some DP format. Again, I have just written the same thing, that it is some subsequence, some format of subsequence, such that some condition is satisfied with the previous element. Now, as I told you previously also, I got the hint of maybe I can try for the DP, which means that obviously I will try for the simple state making and all that stuff, which means I'll go into specific index and then I will see what else I need to get the answer. Then I realized one thing, okay, if I'm at specific index I, which I will have to ultimately go to every index, that is for sure obvious thing, I would need the previous index I saw just now. Why it is required? That will help me to get the corresponding difference. But if I choose the previous index at every index, obviously for every index I will choose for the previous indexes, then my DP state will be I and j. Obviously it will be O of n square, and O of n square would obviously not work in this case. 1e8 will not work. Now what to do then? Okay, just let's see. If I have a value I, when I went and looked at the constraints, I realized, okay, there is a catch. Nums of I is less than equal to 300. Again, this constraint told me, let's try to leverage the value, which is nums of I value. Then I, rather than choosing the previous index, I will choose a previous value, because I am more concerned about the diffs right now. Diffs of two elements, because that will form us the corresponding subsequence diff, maybe, right? So if I choose I as the current index, I know the current value also. If I'm only about to maintain the previous value, that will give me the current diff. Okay, you got the diff. Again, like when I say what about diff, you got the current diff, but did you Forget about the previous diff. But Aryan, why the previous diff is required? Again, you know what this current diff means? Current diff is if I choose an index I, if I choose some previous value j, again, previous index j with a value, let's say x3. So the current diff is x5 minus x3. And again, taking the absolute value. But I am concerned about diff should be in the non-increasing order. So I should also be knowing that with this specific index j, with some value previously, with any possible diff, such that this specific diff is more than or equal to the current diff. That is I'm looking for, which ultimately means I'm looking for some previous diff. I'm looking for some previous diff. Okay, which makes us again to a point that I am making current diff, like the current diff I was making from I and previous value. I also require previous diff, so I also went ahead and went to the previous diff. I will take current value, which is required. I will take previous value, which is required. I will take current diff also, which is required. Doesn't it seem like it is going off? Like again, obviously, if I take the maximum value of diff, which can be there, if you look at the constraints again, nums of I is 1 to 300. Absolute diff value can at max go to 300, because to get the absolute value to be as max as possible, I will put the highest value here, lowest value here. Highest value 300, lowest value 1. Maximum diff can go to 299. That's it. So what to do? Obviously, okay, if I go back, yeah, obviously in this scenario, I realized, oh, I am kind of screwed up, because if I maintain the current diff, which will be 500, current value, again, I'm not even saying index. If I mention the index as what I have to maintain, it will take 1e4. If I maintain the current value, it will take 300. But Aryan, how do you know you have to maintain value or index? I'll come on to it. But I'm saying, okay, what is the possibility? If I maintain the previous value, obviously it will be 300. Aryan, why not previous index? Why to waste the corresponding space? That can be one specific observation here, but I will tell you very clearly why. But we still realize that even if I take 300 or 1e4 from here or 300 here, still it will exceed at the time complexity. But why did it happen? Because you ultimately, again, this is after I'm telling you, you are trying multiple options just to fit your existing knowledge into this problem, but you're unable to do so. So this is what a hit and trial means, and intuition is fitting our existing knowledge to a new problem. So we ultimately realize we need a current diff, we need the previous diff, we need the current value. Again, when I say value, you can maintain the corresponding index also. But as we only need value and the previous value, which means we only need the diff, so I need the current value technically. But even if you maintain the current index, that also is completely fine. I'll tell you why value I'm jumping onto a bit 5 minutes down the line. So in this, I simply realize, okay, it will still give you TLA. Now what to do? Let's again analyze and see what we have and what we want. So I realize if I'm at a current index, I obviously know the current value. Now, to find out the current diff, I will have to go to the previous sum index. So rather than going on to the previous index, I realized I will take the previous value because values are less. Okay, I'll take the previous value. So with current value, or I should say current index or value, and with the previous value, I'll get the current diff. But I also realized that with the previous value, with any other value in the previous portion, the diff which will be made, the diff which will be made for all such diffs which is less than, or I should say that here all the diff which I had should be more than equal to my this specific diff. Again, I just rename it as d new. D new is diff new. All the previous diffs should be more than or equal to my this specific new diff. Out of all those possible diff, again, I told you this is not a hard, like this is not a medium problem. So just be with me. For all the previous diffs, I want to get one such specific diff, or length, which can give me the maximum length, but that specific subsequence ended at previous value, ended at this value, ended at this value. So I need to find in this specific portion, give me the maximum subsequence length such that that subsequence ended at this specific previous value, and has a diff value which is more than or equal to, again, it can be more any value, any higher value, but it should be more than my d new. Only then I can attach this specific new current value into the existing subsequence. Okay, so far you got the result, got the gist. So if, again, this already has given you a hint of why I was referring that I need to have a previous value here, or to be more precise, why I need to have a current value here, because for a current value you're looking for a previous value. You cannot look for look for previous index. Thus, for previous value, any such value in the previous portion, any such value which end at this value having the maximum subsequence length for any diff value more than d new. This is I have to ultimately return, and then if this condition is satisfied, I'll get the previous value. I'll add a +1 because subsequent then increase by adding current value. Now, if I look at this very carefully, I'll simply realize one very basic fact that here I am maintaining two states, current value and the previous value. Here also I realize, okay, I will need some specific value, which is value. I'm playing with only values kind of, it seems like, which ultimately means that I need to maintain value and something else too. But then I also realized I had to maintain the previous value. No, I only need to maintain the diff. What diff? This is I have to store. Why? Because I realized that for any subsequence ending at a previous value with any possible diff, thus my state needs to be value and a diff. But you might argue that Aryan, for the value, okay, value you will get from the current value. But then what about the previous value then? No worries, hold on. But so far you realized that your state should look like value and the corresponding diff. Right? You remembered one thing that we thought of, that we can also take index? We can, but it's unnecessary, and we can only leverage value and diff here. Thus, our DP would involve the value and the corresponding diff. Okay. Now, again, the same question. I might ask, Aryan, what about the previous value? That is still a question. So, simply as we mentioned earlier, we will try for all possible previous values, because that is what I mentioned, right? For a current value, I have to try for all possible previous values. So here I do the same thing, that I will iterate on all possible previous values, and the values are pretty less. Now, you might again get confused by saying, okay, Aryan, I'm taking current value, I'm taking current diff, and then I'm also on top of it taking one more thing, which is previous value. Won't it be giving TLE? No, because the catch here is that obviously you have to go to every index, even if you're making, or even if you are having a DP state of current value, which is a simple value. My value at max can go to 300, and diff also I showed you can at max go to 299. So okay, DP state seems sorted. Current value, current diff. But what about the DP iteration? And that's what makes this problem a bit special. The DP iteration is a bit different, because ultimately you will have to go on to every index. That is something which you cannot run away from. So I will have to go to every index. That is one thing for sure. So if I'm at a specific index I ultimately know the current value also. Then I also told you that I will need to go to all possible previous values. Because why I have to go to previous values? Because I cannot go to previous diffs. Diff cannot give me the value specifically I want to go to, is because previous value, let's say, if say this is a corresponding previous value, which is one such value, this if I have to find what is the ending subsequence maximum length ending at this specific previous value whose diff value is more than or equal to this diff between x5 and x3. Thus, I realized that if I go back, if I go down for the current index, because I will have to go to every index, I will look for all possible previous values. Now, I will exactly show you that how you can write it. But before you go on to, you must have one doubt. Ultimately, that are you okay for a specific index I? I'm going and trying for all possible previous values. For every possible previous value, I will know the diff. Okay, I will know this specific. Okay, if I just read it, I'll know this specific diff, which is I have named it as d new. This is the previous value. Then you are saying that in your DP state, you have stored that up till so far, any subsequence which is ending at prev value, which means I will have value, and any possible d, again d variable, any possible d, such that this specific d is more than or equal to my d new, right? You want any for any possible d which is more than equal to d new, you want the maximum length, which means out of all such d's, you want the maximum length. This is ultimately what I have also shown you, that you want the corresponding maximum length. Okay, let's erase it. Yeah, maximum length, which brings you to one very interesting fact, that for one index you're going to all previous values. For one previous value, if you go to all possible diffs ending at that specific previous index, it will give you a n for the current index. Previous values can be 300 and diff value possible can be again 300. Because it is 1e4, this will still give you a TLE. How to optimize it? Just do the same thing. Simply keep track of the maximum length. Because ultimately, what you did here, you just want that out of all such d values which are more than equal to your d new, just give me the maximum length. This was the extra iteration which was taking a 300 time extra. They simply do the one thing. Simply make sure that you do the pre-computation. Because you are maintaining all such d values, maximum length. So for the suffix as in anything which is higher than d new, again make sure d new is the current diff. Anything which is higher than d new, if I just simply erase it, yeah, anything higher than d new, you just simply maintain its corresponding maximum length and keep it in a variable or a data structure, simple array, name it as suffix max, and simply maintain that so that this extra factor will go away. So what I did, I maintained a suffix max with a value, but here this value will be used because for a subsequence ending at a previous value with any diff, right, more than or equal to d new, sorry, it should be more than equal to any diff which is more than equal to d new, you maintain that maximum length in this suffix maximum. Why suffix? Because you are taking everything higher than d new, higher than or equal to d new, and maximum because you are maintaining the maximum length. And thus with this simple array, I can in O of one time, rather than iterating on all the diffs from my end which are more than equal to d new, I have now pre-computed it. And that's what I can use to leverage and to ignore this specific 300 iteration time. Let's see the final code. Firstly, so far you must have realized a very interesting fact, that because of such a complexity in the state and in the iteration, that you will and you should use a bottom up DB approach. Now you might say, Aryan, okay, I can replace this specific state with I. Yeah, you can. and with that you will no more be needing current value, rather you will take index and the current diff. But at the same hand, you will still need to iterate on all, like obviously this I will make sure you iterate on the current index, but then current diff, again, it can be implemented in top down but will become a pretty complex. Bottom up will be pretty straightforward, that you go to all the indexes, right? You go to all the indexes, every index one by one. For every index I told you, you have to go and try for all possible previous values. Now, previous value can be anything. You can maintain a set also and take, okay, what all values which I have maintained previously are there. Again, you might see that I have missed purposely the base cases, which I will show you when I will show you the corresponding code. But I'm just giving you a summary of what all I told right now. Then for every index, I go and try for all possible previous values. For a current value and the previous value as a pair, I know the dnew or the current diff, which is simply the absolute difference. If I know the current diff, I know the previous value or the previous num. In the code, I will reference this by previous num, prev num. But for the prev num, any subsequence ending at prev num having a difference higher than or equal to dnew, I told you I will maintain it in my suffix max, which is max length so far. Let's say max length so far, I will maintain that in my suffix max, which is ending at prev value and difference higher than or equal to dnew. I simply got this from my suffix max. When I have got the maximum length so far, I have got the corresponding current difference also. Simply just add a plus 1. As simple as that. I did the same thing. If the max length so far is more than 0. Now, what does more than 0 it ultimately means here? More than 0 ultimately means that, okay, you already have a subsequence ongoing, which means you already have some subsequence which ended at prev, num. You already have this thing. You just got one more thing, which is at the current index I have the value num. This is one more thing. So in the existing length, just add a plus 1. So I did the same thing. I have to maximize it. So make sure always this thing is always, when you have to maximize it, take the same thing here. And then in the existing length, plus 1 because of the incoming element. Now, you might ask, Aryan, why you have added if condition? Because what if there was no maximum length? Which means that nothing like this, no subsequence already. So if there's no subsequence already, I can start a fresh subsequence. How? Which means this is the starting point. If this is a starting point, which means these are two pairs, starting two pairs. So in the beginning, if it is a fresh start, the length will be 2. So I did the same thing, that if there is no subsequence so far, then fresh start will say length of 2 because of two elements. And again, as in the same thing, I just try to maximize my corresponding dp value, because again, I told you dp will store that for the current value of num with this specific difference, what is the maximum length I can achieve, right? Now, you did this specific portion in which for every index, or I should say for every num, you try for all possible previous values. But did you see one thing, that you were leveraging suffix max, but in this piece of code you never updated it. And it is a very important thing that you cannot also update inside this loop. Inside this prev loop, you cannot update your suffix max. Else it will become n into 300 into 300 as a time comparison, which will TL. What to do now? Obviously, as this loop complete, another loop will start off, which will complete that pre-computation step. What is required? I require for any specific value ending at num, for any difference higher than or equal to, any difference higher than, again, what I'm maintaining is suffix max. That if I have a dnew, then any possible d which is higher than or equal to dnew, any possible which is higher than or equal to dnew, for all such values, whatever is the maximum value should be stored in the suffix max of ending at any num, which is the current num itself, because I am in the num loop itself for the current num. For dnew will say this suffix of dnew. Let's say here is diff, but let's say if I replace this diff with a dnew, it will say that go and get me for all possible d which are more than or equal to dnew, just get me the maximum out of it. Thus, I'll do the same thing. That I'll take the suffix maximum. Suffix maximum, as you can see, for a diff, go and try for diff plus 1 and maintain the suffix maximum. Now you might say, Aryan, but everything is suffix maximum, but you did not use a DP here. Obviously, yes. So what I will do, simply I will initialize my suffix max of the current num with a value, let's say, of 300, which is, again, the diff can be anything whatsoever. Okay, let's say if it is 300, which we can have. So I can just simply initialize by saying dp of num and the corresponding diff, which is as a 300 in this case. And thus, I can initialize it, use my dp, and keep on updating my answer. Or I should say suffix maximum. But this happens separately out of this specific loop. So this is n into 300. Then this portion is n into 300 again. Cool, let's see the code. It's exactly very same as what I told you. Firstly, I told you that I will need a dp which will maintain the current num, and also, as we saw, that we need to maintain difference. So I'll also maintain the corresponding difference. Again, here you can take the size as 300 also, because maximum difference value can go to 299. Okay, same way for suffix maximum also, I will take again my num and again my corresponding difference. Here the difference value again can be taken up till 300 because the maximum value can go up till 299. Now actual fun part starts. In the very beginning, safe case, one subsequence of one element is always one subsequence length. Then go on to all the specific elements, all the indexes. Then again, you might ask, what is this? It simply means a simple base case that for any num having no, what this 0 indicates, if you forgot, then this 0 indicates the corresponding diff. I have no diff. I have no diff at all, because by default the values are 0, which means I have no diff. If I have no diff, the corresponding dp value is 0, right? If it is 0, which means for a specific num and no corresponding diff for me, I have it 0. Okay, simply initialize it by 1, which means a starting 1 length. These two are the same things, giving you a starting 1 length, because one element is always 1 length for me. Now, if that's the case, for every num, I told you that we have to go to all possible previous num values. With the previous num, I will get the diff new d, and with that new d, or the current diff, or the current diff value, I'll find the best possible maximum length, or maximum chain length so far, which is a suffix max. If that maximum length is more than 0, simply maximize it by doing a +1. If it is not, then go and check it. Again, if you must have seen, okay, I wrote this condition, but then I also mentioned the same thing on the side, that considering previous exist, you can, again, here if you remember that for a specific num, I'm trying for all possible previous value, but a subsequence of length 2 can only be made if you have your num and you also have your prev. The prev exists there or not will be indicated by saying that if the suffix max for that specific prev value, if it is more than 0, which means, okay, I have a specific prev value previously. In that case, simply maximize your answer with the prev value. And again, as this portion is being done, make sure to maximize your answer with the current dp. Now, when this portion is done, I know that ultimately I will start off by trying my corresponding suffix max. And again, as I told, my diff, maximum diff itself starts at 299. So that's the reason I start from 299. I maybe missed by saying 300 here, but it should start from 299 itself, and then it will go from 298. Cool. And then I will start off by going simply backwards, because I'm taking suffix max of all possible diffs, which is higher than equal to my current d. Thus, I'll be grabbing maximum, which is a separate for loop, and ultimately getting the answer. As I can simply show you in one glance, my n go on to all the possible n elements and then 300 and then 300. Because you are simply using 300 into 300 dp state into 2, thus the space is 300 into 300. But as you know, that time is n into 300 plus n into 300, which is n into 300 into 2, which is again n into 300. And thus, this is your answer. I hope you guys got it. I hope you guys got the complexity behind analyzing state, possible options, and all the stuff. If you guys liked it, again, if you think it was a bit confusing, no worries. Go and watch the video again with taking a bit pause. I was in no mood to do a dry run for the basic subsequence pattern because you can just simply write longest increasing subsequence by Aryan. You'll get the video. Watch it, understand it, come back to this one, watch it from an open mind. Bye bye.